Hello, this is my lab report for magnetic braking with Faraday. The purpose of this lab is to experiment the Faraday's law by inducing an external magnetic field by following a bar magnet. For this lab, we first collected data of the magnet falling through the aluminum foil tube, modeled the interaction computationally, and compared the predictions to the observed data. The results I got from the experiment was 1.6 seconds, whereas the result I got from the computational model was 1.754 seconds. Three physics principles used in this lab are the Faraday's law to find the current in the tube, Biot-Savart's law to find the force on the aluminum tube, and the Newton's second law to update the velocity and position. For the experiment, I first marked the end pole of the magnet using the magnetometer app. Then I held the aluminum tube vertically and placed the bar magnet above the tube. I recorded the time it took for the magnet to go through the whole aluminum tube. These are the measurements I got from the experiment. It took 1.6 seconds for the magnet to reach the bottom of the tube. Length of the tube was 0.3 meters, width of 0.01 meter, and the mass was 0.023 kilograms. This is the results of the computational model. To the left is the magnet falling in the tube. The black cylinder is the aluminum tube. Red ring is the current below magnet, and the blue ring is the current above the magnet. To the right is the velocity versus time graph of the falling magnet. In conclusion, it took 1.6 seconds in the actual experiment of the magnet to reach the bottom of the tube, but the computational model, it took 1.754 seconds, which was slightly longer than the result from the experiment. I can infer that this is due to human error or errors in measurements. For the computational model coding, I first had to initialize the graph, then create the aluminum foil, and create the bar magnet. And then I created the function to calculate the magnetic field of the bar magnet, and created the function to calculate the magnetic flux, and lastly I created the simulation loop. If the resistivity of the conductor were reduced as close as possible to zero, the magnet will fall slower and start floating when the velocity reaches zero, because the magnetic force will keep increase until it is equal to the gravitational force. If there were holes cut into the tube, the magnet will fall faster than before because the magnetic force will increase since the induced current will decrease. Thank you for listening.